All right. So basically, I first think about what data I'm going to have. Those are going to be my instance variables, and then what abilities. What can my class do? Those are going to be my methods. Now that I've done that planning, I can go ahead and start to write my code. So I'm going to open up JGrasp here. I chose rectangle because I think most of us know rectangle from geometry, and you know you have to have taken geometry to fulfill the requirements to be in the seats here. So I'm going to do, and I'd like you guys to write this with me, file new Java, and we're going to write a rectangle class together. Yesterday I did a lot of scaffolding when we were writing our classes together. Remember, I had all those comments and we went through it. So if you're still struggling on class and objects, I would go through yesterday's activity where there were tons of comments. It was very scaffolded. But today we're going to kind of go through it a little bit quicker. Up at the tippy top, I always put my class header. I say public class and then whatever the name of the class is with a capital letter. In this case, I'm defining what a rectangle is, so I'm going to say rectangle. And I know that's not very different than what we've done since the beginning of the year, but here we're saying we're defining a rectangle. Instead of just using a class name to name your file, I'm going to go ahead and use my class name to say what I'm defining, the type that I'm defining. Here I'm defining the type of a rectangle. I already have a rectangle. Okay, I don't care. I'm just going to save over it. So I always write my class header up at the top. If you don't want to write the comments, that's fine. I guess I maybe will toss them in here just for people watching the video, wherever. Class header. Next thing I usually do is I do my instance variables, aka my data. And we said the data for a rectangle, are going to be ints representing the length and the width. Our instance variables are always private, so I'm going to say private int length, and since the width is also a private int, I can declare it on the same line. If it's different types, I'll declare them on separate lines. I mean, different types I'll declare them on. I don't know why I said. Different types declare them on separate lines. Same type declare them on the. Hey, how's it going? I'm doing all right, thank you. Next, I usually write my constructors. Right next because I want to be able to create an object like that. Now there's two types of constructors you're going to have. There's like a default constructor, which usually takes no parameters and you choose values for the length and the width. And then there's also a specified constructor, where you can actually choose a specific value when you create your rectangle for the length and the width. Why don't we write just a default one first? Default ones are pretty straightforward. Josh, you logged on?
Yeah.
All right, I can give you my screen here. Let's see, Finn, the mighty Finn. Is this you?
Thank you.
No problem. All right. Default constructor. Constructors are always public. If you don't believe me, you could look at your notes on constructors. Constructors are a special type of method, and they never have a return type. So where I'd usually say public void, public int, public double, public string, here I just say public, and then they're always the same as the name of the class. And since my class is named rectangle, I'm going to name my constructor rectangle. Sorry about the gratuitous space there. There we go. Now for default constructors, sometimes they're called parameter list constructors because you're just quick and dirty making a rectangle, and the programmer gets to choose the values for the length and the width. And so we don't put any parameters there. Left brace, enter, enter, right brace. And then in a default constructor, the programmer really gets to choose what the values of the instance variables are going to be. And the programmer wants to choose something that makes sense for a default value, where if you looked at it, it wouldn't affect your program in any way that it's a default value. But you'd also be able to look at it and go, oh, that's probably a default value. I should change that. For length and width, I think it would be good to make them 0. Because if I saw a rectangle with a length and width of 0, I'd go, yeah, that's probably needs to be changed. And if you don't know what this is for, the whole point of a default constructor is so you can quick and dirty make a rectangle. So that I could do something like that, and it would make a rectangle. Now, obviously, the rectangle would have a length and width of 0, so if I wanted to change it later, I would need to have like setters and stuff like that to actually change the length and width and whatever, but this will allow me to quick and dirty make a rectangle object. Questions there so far? Okay. All right. Then I'm going to go ahead and make my specified constructor as well. Specified constructor basically means at the time of creating your rectangle, the user is going to choose values for your instance variables. Well, okay, it's a constructor again, so I make it public. Constructors are always the same as the name of the class, rectangle. And the difference is, instead of having no parameters, I need to have parameters for all or some of the instance variables. And if you don't remember how to do this, we have done a worksheet where you wrote mini constructors, just as a review, but since length and width are my two instance variables and they're both ints, I want to have two ints that represent the length and the width come in. Yesterday when we were writing it, we said you could do the length, you could do something like that. My length, you could do something like that, or you could just say something like L. I don't like putting L because then 5 people put the number 1 even though I'm saying the letter L right now. L, yeah. That's kind of funny. Oh. I'm going to put L anyway and hope that people have heard me say that that is an L and not the number 1. And then I also need a integer representing the width. This confuses people sometimes because they go, hey, aren't both of those integers? Can't I just say int once? Well, yeah, I understand what you're saying, but the issue is we can put many parameters in here, so what if I had a string? I'd have to specify that. What if I had a double? I'd have to specify that, and so on and so forth. So for your parameters, and we learned that these are called formal parameters, these placeholders, you always need to declare them and name them. Now the idea is, okay, I need to give values to the length and width. When I'm doing that, the instance variable goes on the left side of the equal sign, and then on the right side of the equal sign goes my formal parameter, L, not the number 1. And I'll do the same thing with the width. If you switch these, if you do L equals length, that's wrong. It will not work. You will not create a rectangle very well. I'm going to go ahead and compile again, just to be safe. Now, again, having these two constructors at this point, if I wanted to use the default constructor, I could just do something like this. The issue would be that they would both have a length and width of 0. Now I also have this other constructor where I can specify the values for the length and the width, and I could just say something like that. And 3 would get passed into this L value, and then 4 would get passed in for this W value because of the order that they're in, first, second, first, second. 3 would get assigned to length, and 4 would get assigned to width. That's what's happening right now with this other constructor. Okay, I've diagrammed it, I've explained it in English, I've written it in Java. We're good so far? Okay. Alright, so those are my constructors, and again, they just quick and dirty allow you to make objects super duper quick there. They're like object factories is what I call them. If you don't believe me, I'll just demonstrate it really quick down here. You don't have to do the same. I'm just showing you something. If I go ahead and hit enter, you'll see that a rectangle object named R is created that has a length of 3 and a width of 4. So that's what a constructor does. Okay. Moving on. We said what other abilities? Let me look at Microsoft Paint here. Getters. Okay, getters are accessors. Getters, aka accessors. We need getters or accessors so we can isolate and get the individual values for our instance variables. We don't have that data from outside the class because those instance variables are private. So we need to make these accessors, or getters. Accessors are always public. That's the whole point of them. I'm not going to make you get out your note sheet right now if you don't want to, but we said that accessors always return the same data type as the thing we're trying to get. So if I want to get the length, since the length is an int, I need to say I'm going to return an int. If the length were a string, I would say return a string. If the length were a double, I'd say return a double. Here I'm saying this method is going to return an int. Next, we name the method. There's a reason we call these getters sometimes. The way we name them is we just say get, followed by the name of the variable we're trying to get. And we camel case, of course. So get length, get width, get name, get whatever. Accessors have no parameters, but the parentheses are mandatory. And then the body for the method is super duper simple. Left brace, enter, right brace. All I do is say return the length. And again, if you're wondering why do I need one of these, well here, I'll do a quick demonstration. If I make a rectangle object, if I try to just figure out what the length is like this, it'll say you can't access the length. Length is, I can't find it, I don't know what it is. But then if I do like r.getLength, now it'll tell me what the length is because I have this public method versus a private instance variable. I can figure out what the length is immediately. Go ahead and write the same one for the width. I'll write it with you since it's, you know. Those are accessor methods. You just need to make sure that this, whatever this is, matches the type of this. Length is an int. So when you say I'm going to return something, this is like a contract. If you say you're going to return an int, you better return an int. If you return something else, it's not expecting it. It's like square peg, round hole. Not going to work. Questions on accessors. What the point is, what they do, how they work. Why? Okay. Next, we'll do our, what did I say next in Paint? Setters, our mutators. All right. These methods are going to be completely useless if I make them private. What's the point of making a private mutator when I can only use it inside this class? There's no point here. So I'm going to make my mutators always public as well, just like the accessors. We said the return type of a mutator or a setter is always void. It never returns anything. It just changes a value. Just changes a value. It doesn't return anything. It just changes some value. And there's a reason we call them setters kind of colloquially, less formally here, is because we always call them set, followed by the name of the variable that we're trying to change. And again, the whole point of mutators, if you don't get it, is it allows you to change the instance variables for an object after you've created it. Imagine if, like life, when you have a birthday, your age just goes up. If there weren't mutators for your age, they would have to come and kill you and then clone you and then make somebody else that is your age but one more. We don't want to completely destroy an object. We want to just be able to change the data for an object. Can you imagine if every time your Pokemon took some damage and whatever, instead of just having the health change, that they actually killed your Pokemon and cloned it and gave you a new Pokemon with slightly less health? What a cruel world. Instead, we've already made an object that works. Let's just go ahead and modify some of the details about it. Now, I do need to take in a value, much like a specified constructor, so that I can change the length to something. So since the length is an int, I'm going to take in an integer representing the length. I know they're singing outside. I wanted to keep it open so I didn't look like the Grinch or anything like that. And slam the door on their singing, smiling faces. Okay. I should have closed it and say, no more noise, noise, noise. Now, just like your specified constructor, I need to go ahead and do a line that looks like length equals L. This is an L. I know you know it has to be an L because I know you know variable names can't start with a number, you little stinker. So that is an L there. And if you're wondering, what's the difference between a mutator and a constructor? A constructor creates the object. A mutator changes the object after it's been created. They have two different things. A constructor is like the birthing process, and then like a mutator is kind of like plastic surgery. Let's say that. Obviously, I'm going to write one for the width as well. Basically, mutators allow you to change the data that you're born with. Okay, we're getting somewhere. Or at least it feels like we are, to me. Let's see. We got instance variables, default constructor, specified constructor, accessor methods, mutator methods. Let's see how we're doing in Paint here. Yes, yes, yes. Okay, and yes, and yes. We still got just a little bit of work to do. Questions so far? All right. Two-string method. What does a two-string do? It basically returns a string that shows you the data of your instance variables. It's like a baseball card. It lets you see what's the length of my rectangle right now, what's the width of my rectangle, stuff like that. And you can format it really however you want to, but it must return a string that's representative of the data of your object. The nice thing about two-string is it always must have the same first line. It always looks like this, no matter what class you're writing. If you're writing a guitar class, if you're writing a Pokemon class, if you're writing a car class, whatever, it always has to look like public string with a capital S, two-string with a capital S. It always, always, always looks like that with no parameters. Always looks like that. Now again, it's up to you what it looks like. Here's how I personally would format mine. I would like mine to look like a string that says length, followed by whatever the length is, and then width, followed by whatever the width is. As one single string. Does that kind of make sense, what I want? Okay. So I can do it in one line, if you guys are comfortable with that. Okay, I'm going to say length. Since I want the actual word length to show up, I put it in quotes. If I want a colon to show up, I leave it in quotes. Now I want the actual value of the length, so then I close the quotes and say length. And if you're wondering, how do you know what the length is down here? Well, when I declared length up at the tippy top all the way up here, that means it's usable anywhere inside of this class. Its scope is anywhere inside of the class. It's kind of like a bunch of rectangles. This is my class. If I declare a variable up here, if I say private int whatever, up at the top, then it's usable anywhere inside of the little methods that are inside of my class. They can also use the width as well. It's visible to all of them. How do I do a new line? \n. You guys are good. I think that'll look lovely. Now, if you goof it up, you always make sure you got open and close quotes, and then a plus sign. And then a plus sign again before your open and close quotes, and then a plus sign. Now, if you're wondering what's the point of a two-string, I can show you really quick. Anytime you make an object, if you go and try to print out that object, if you try to print out an object, Java knows to automatically go find your two-string method when you print out your object, and so it'll look nice like that. Now, if you don't have a two-string method, if I'm a silly Billy and I forgot to write my two-string method really quick, let's see what happens instead. I go ahead and I make a rectangle. I go ahead and I print out the rectangle here, and I get this instead. More informative or less informative? Slightly less informative. Slightly less informative. Okay, so if I don't have a two-string method, I get that gobbledygook. If I do have a two-string method, I get what I want. Okay. Whew! Now, believe it or not, you've just written methods that you're going to have in your classes no matter what. We've just done boilerplate stuff so far. Now we get into special stuff. Things that are special to a rectangle. I usually kind of call this section in my classes special methods, because they are methods that only deal with your specific class. Obviously, if you're writing a class that represents cars, there's going to be some stuff like accelerate, brake, fill up with gas, etc. You're not going to have a fill up gas method with a guitar class, something like that. All right, now let's see here. We said area. Okay, when we're writing our own methods, which you did yesterday and last night for homework, we are going to say public first of all. Oh, let me say this is the area method. I'll say it's public. Then next in the method header comes my return type. What's the area going to be? If the length and width are an int, and we calculate the area by doing length times width, I'm guessing the area is just going to be an int itself. Yeah. Does the logic hold? The logic holds up. Now, if I just wanted to print the area, I'd make this method void, but I'm not going to be printing the area. I actually want to calculate it and return it. I think area is a lovely name. And unlike your methods last night where you needed a bunch of parameters, the only thing you need to calculate the area is the length and width. And as we already said, every rectangle already knows its own length and width, as those are its instance variables. So I actually don't need any parameters here, unlike the triangle one that some of you might have done last night. Now, you can split it into two lines if you want to. You could do something like, I don't know, the area equals length times width. And then you could return the area. Or I suppose you could do without a variable and just take this thing and say return that calculation. Really up to you there, however you want to do it. Some people might find this way more readable. If you're wondering why did I name this the area instead of area, I think it's confusing when I have a method named the same as a variable inside of that same method, so I'm not going to do that. Now, what does that let me do? Well, what it lets me do is at some point I could go ahead and create a rectangle and figure out its area. Here, I'll show you. I could create a rectangle, and then I could say, okay, go ahead and print out what the area is. Wait, I didn't compile my code? I'm so sorry. How rude of me. Let me try again here. I know. Always compile. I'm not even following my own rules anymore. What am I doing? There we go. Rectangle's 12. Okay. That's the area method. Before we move on to the perimeter, any questions on this one? Remember, I'm returning it. I'm giving it back, so that's why I have a return statement there. Okay. Perimeter. You guys can probably write the perimeter method, right? Yeah, why don't you guys go ahead and write the perimeter method? I'm going to walk around and help people as they're writing it. I would kind of make it look similar to the area method, but slightly different. Trail here, okay. No, yeah, the perimeter. Public int perimeter seems like a good as name as any. Some people wonder, okay, why did we make length and width variables, but perimeter is a method? Well, I can calculate the perimeter based on the length and width. I need the length and width to find the perimeter. I don't really need the perimeter to find length and width or etc. I can figure it out. Basically, a rectangle at its very most base is just a length and width, and the rest of the stuff can be found out from that length and width. So it kind of depends. Here, I'll show you a one-liner. You can do 2 times length plus 2 times width. If you want to do it on one line without a separate variable, you can just do your return statement right there. And then a couple people were doing the diagonal one. I was pretty impressed by that too. The consideration that comes into play when you're dealing with the diagonal, you have to think, okay, if I have the length and I have the width, how am I going to find this diagonal? Well, you guys are seeing it's a Pythagorean theorem situation. I basically have L and I have, well, hold on. What would you say this is? W? This is L? I don't know. But you basically get W squared plus L squared equals whatever the diagonal squared is. Then you'd have to square root both sides, so D is equal to that whole thing. So what do you think would be the return type there? Probably a double because we're square rooting some stuff. Unless you're guaranteed it's a Pythagorean triple, you're probably... I can tell you for a fact I know square root gives you back a double, so public, double, diagonal, and I'll go ahead and... Okay, long mathematical formula incoming. Return math dot square root of... Now, I could do something like this, but you guys would never forgive me for it and let me live it down, so I'm going to do math.pow, length to the second power, plus math.pow, width to the second power. Well, one more paren. There we go. Length squared plus width squared, square root of that whole quantity gives you the diagonal. Questions on that? So, while you folks are finishing writing that down, let me just look at our checklist really quick here. We did perimeter, we did diagonal, we got our instance variables. We have defined the class with everything a rectangle is, everything a rectangle can do. We got our verbs, which are our methods. We got our nouns, which are our instance variables. We're looking pretty good. Why don't you take a 2-minute break, and we'll do. I'll write a tester up to show you what you could do for a tester real quick. But you go ahead and take your 2-minute break there, and then I was writing up some code to test it really quick. I want to show you guys kind of what I'm doing here. You don't have to write this. I'll kind of post an example, but you can see my screen? Oh, okay. So you don't have to type all this out. I'm just showing you what a tester class would look like. I have my rectangle.java over here. It's got all the definition, all the methods, all the instance variables, all the constructors, accessors, mutators, and toString. Everything I could possibly think of for a rectangle is inside of rectangle.java. Then you might be asked to make a tester method. What does a tester method, or excuse me, a tester class do? In a tester class, you're essentially showing that your methods were public and you can actually use any of the methods, use any of the code from the other class inside of another one. This is common and this is how it's done in the industry. So you can see in this one, I've created a rectangle using my default constructor. How does it know it's my default constructor? Because there's no parentheses or no parameters. Then I go ahead and I print it out. This will call its toString. Then I went ahead and called the mutator methods to change the length and width and printed it out again. So far, this is kind of what my tester looks like. It says this is a default rectangle. I'll call its toString by printing it out. Length and width are 0. Now I'll change the values of this default rectangle using mutators. So I've got my set length and set width method. You'll notice that the length and width changes. Then I said here's the length alone using its accessor. And so I called the getLength method. I said I could create another rectangle using just its specified constructor. I could do something like this. Rectangle R equals new rectangle. And does anybody know another Pythagorean triple? Is it like 5, 12, 13?
Yes.
Okay, thank you. So I could do 5 and 12. And then I could go ahead and print out R, something like that. And now I should see a new rectangle that automatically, immediately has a length and width of 5 and 12. And then I could call other methods. I could say something like, here is this rectangle's diagonal. And then I could toss on r dot diagonal. Something like that. And I can see what the diagonal of this rectangle is. And indeed, it is a Pythagorean triple, so I get 13. So this is an example of writing a tester class where I've got a default rectangle created up here, and then I also have a specified rectangle created, and then I call a bunch of the methods on it. So, just one more time. The class is what goes ahead and defines all of the data, your instance variables, as well as all of your methods. Most of the methods, no matter what class you decide to write, you're going to need like default and specified constructors, accessors, mutators, two-string methods, and then there are a couple methods that are special depending on what class you've written. And then secondly, after I went ahead and created a rectangle, then I made a separate class that just goes ahead and tests the functionality of my rectangle class by creating a couple rectangle objects and calling methods on them. Any questions? Okay. Then it's time for you guys to do. On the classroom, I put up, Mr. Foster posted a new assignment, Project 3, Classes and Objects. I'm just going to pull up the instructions here real quick. Here's the project. It's much different looking than the other projects we've done. It says Classes and Objects, create your own. Pick anything. A car, guitar, video game character, clothes, polynomials, fantasy sports. Now, you should pick a general. You should make like a class called car. Don't make a class called my 2003 Toyota Corolla used. Don't make a class called that. Make a class that generally defines something. So I notice I didn't make my specific rectangle with a length and width of 3 and 4 respectively. I created a rectangle class. You could create a car class, guitar class, video game character class, clothes class, polynomials, fantasy sports, etc. You need to have at least 3 instance variables. Depending on what class it is, you might have different instance variables, but make sure you can do stuff with the instance variables. So for example, you could do something with somebody's name. You could figure out how many vowels there are, stuff like that. Setters for each instance variable. So those are your mutators. Getters for each instance variable. A specified constructor, which I just wrote. A default constructor, a two-string method, and then you need at least one special method specific to the class. You notice in the rectangle class I wrote 3 special methods. You could do that if you'd like to, or you can just write 1 if you'd like to as well. Then it says create a main method and a runner or tester class, however you want to call it, that demonstrates the class's abilities. That's what I did secondly over here, was I just created some objects and called methods on them. And then there's some requirements for there as well. I did say your project may not look like the project of the person next to you. This inevitably always happens. And then 2 people do, like, one person does fantasy football running back and one person does fantasy football wide receiver. And they go, they're different, Mr. Foster. I go, oh, what's the difference in the calculations? Nothing. So no, those would not be different. So your project may not look like the project of the person next to you. Do something that's personal and private to you. If you play a sport, maybe define the equipment for your sport. If you play an instrument, maybe make a class that defines the instrument. If you like fashion, make a clothing class, something like that. You may also use processing if you'd like to instead, kind of like how we made that ball class a few days ago. You could do something like that in processing if you'd like to. As well as an option. So if you'd like to do something in processing, you can do that. Obviously, if you're going to do something in processing, it can't just look like the ball class but be a square bouncing around instead of a circle. It'd have to be like your own thing. And it's pretty open-ended. That's all of my. There is a rubric on the second page, but that's it. So if I were you, what I would do is kind of think about what you want to do, maybe go through a planning process like I did. Think about what data, you need at least 3 different data instance variables. And make sure whatever you choose, you can calculate something based on those instance variables. Some people think, oh, so I can't use strings? No, you could use strings. For example, let's say you're making a guitar class. You could have the body of the guitar, the wood body of the guitar, be one of the instance variables as a string, and you could say something like, if it's Brazilian rosewood. it costs this much money. If it's maple, it costs this much money. You could do something like that is fine. You could figure that stuff out about strings as well. Somebody doesn't have their chaperone. So that's what we're doing the rest of today, all of tomorrow, and then whatever time you need over the long weekend as well. And I think I wrote, I'm going to have you guys show them to me, turn them in on Tuesday at the beginning of the hour. So you have the next 23 minutes or so in here, and then all of tomorrow as well, and then whatever extra time you need over the weekend to do it. Okay, if you want to listen to music while you're working, you can. I'll let you loose on it.